In this video, we'll take a look at a new concentration called molality. This particular concentration, in addition to telling us the amount of material in our solution, it's also going to have an impact on our solution properties. So that's why we're bringing up this new concentration. So our new concentration we're going to talk about in this video is molality. We represent molality with a capital M, a lowercase m. So we've got to be careful. We've got molarity with the capital M. We have molality with the lowercase m. Molality is moles of solute per kilogram of solvent. Now, when we start talking about solution concentrations, we said it was going to be important to distinguish between the solute, solvent, and solution. And this is one of the reasons why. Remember when we talked about molarity, capital M, that was moles of solute. Molality here, I have moles of solute. The difference is what we are comparing it to. So with molality, that was moles of solute per liter of solution. So your total mixture. But with my molality here, it's moles of solute per kilogram. So first of all, we got mass here. And then it's not the entire mixture, it's just relevant to the solvent. So it's moles of solute per kilogram of solvent. So if we take a look at an example, we're asked the molality of a solution prepared by dissolving 3.86 grams of glucose in 155 milliliters of ethanol. So if we break this down, again, identify our solute, solvent, and solution. So we are dissolving 3.86 grams of glucose. So the glucose is my solute. It's being dissolved in 155 milliliters of ethanol. So that is my solvent. The solution is the glucose plus the ethanol. Now we are being asked for the molality. So molality, we've got to look back at that definition. It's moles of solute per kilogram of solvent. So to find the molality, we need moles of our solute glucose divided by kilograms of our solvent, the ethanol. So in terms of our solute, we're given the mass of glucose, and we're going to need to convert that to gram, or we're going to need to convert those moles or those grams into moles. So we've got grams of glucose, we need moles of glucose. We're going to convert between grams and moles using our molar mass, which is 180.12 grams per mole. So we're setting up our conversion. We take the 3.86 grams we were given, we write it as a fraction over 1. We're multiplying by our conversion factor using this molar mass equality here. We need to cancel grams, so we're taking the gram side of that equality, we're putting it on the bottom. The 1 mole side, we're putting it on the top. So we're dividing the 3.86 grams of glucose by 180.12 grams of glucose, which is going to leave me with 0.0214 moles of glucose. So we've got the first thing that we need to calculate that molality. Now the other thing we need is the solvent kilograms. So in terms of our solvent, we have the solvent volume. We need the solvent mass. We're always going to relate volume and mass using density. And we were provided with the density of the solvent. So we were told that that solvent density was 0.789 grams per milliliter. So that means we've got 0.789 grams of ethanol in 1 milliliter of ethanol. And we're just abbreviating this ETOH. So ET for the F, the OH to indicate the alcohol. So we set up our conversion. This time we need to cancel volume. So we're putting the volume side of that equality on the bottom, the gram side on the top. That way the milliliters cancel. We multiply our volume, 155 milliliters, times the mass, 0.789 grams. That would give us grams of ethanol. Molality, we need kilograms, so we're using the definition of a kilogram, that 1 kilogram is 1,000 grams, and we're going to get 0.122 kilograms of ethanol. So now we have what we need to calculate that molality. We take the moles of our solute divided by the kilograms of our solvent, which is going to give us 0.175 molal glucose in ethanol. So looking at our problems, when we come across that lowercase m, it's important that we recognize what that lowercase m stands for. And remember that lowercase m, it's the molality, and it is the moles of the solute per kilogram of the solvent. So if we look at our next problem, number 7, we've got a solution containing 27.950 grams of sodium hydroxide in 400 grams of water. And we're asked for the molality of the solution. So again, we know how to break this down. My solution contains sodium hydroxide. So that is my solute. It's in the water. So that is my solvent. We're looking for the molality. So for the molality, I need moles of the solute. So I'm going to need moles of sodium hydroxide divided by kilograms of the solvent, which is water. So looking at the information we have the mass of the solute. So we're going to take that solute grams and we're going to convert it to moles. So my 27.950 grams of sodium hydroxide. I set up my molar mass. My molar mass of sodium hydroxide is 40 grams per mole. So 1 mole of NaOH over 40 grams, which is going to give me 0.69875 moles of my solute. My solvent is the water. We need its kilograms. 400 kilograms is going to be 0.4, or 400 grams is going to be 0.4 kilograms. So my molality, 0.69875 divided by 0.4. Looking at my significant figures, the 69875 has 5 significant figures. The 400 grams converted to kilograms has 4 significant figures. My answer is going to need 4 significant figures. So we're going to get 1.747 molal. So again, this molality, you're not going to typically find it written on a bottle in a laboratory. You're most likely going to see molarity. But we're going to use that molality specifically in calculations associated with solution properties. So we're going to have to be able to, at some point, convert between units. So if we've got a molarity, we've got to convert it to molality. Or in our next video, we're going to take a look at percentages. We have to convert percentages to molalities as well.